Alright, for the final question in our factorial discussion, a hard difficulty one, we're going to try to reduce n plus 2 factorial over n minus 1 factorial. Now, just as an overall goal, we're going to try to express each one of these in terms of n factorial. And we'll take each one case by case. So let's look at n plus 2. Alright, so n plus 2 factorial is n plus 2 times every number before it. So the number immediately before n plus 2 is n plus 1. And a handy way of saying n plus 1 times every number before n plus 1 is n plus 1 factorial. This should make sense, because this number factorial is equal to this number times the factorial that precedes it. Now we do the same treatment to n plus 1. So we now have n plus 2 times n plus 1 times the number before that, which is n factorial. Which is exactly what we were driving at. That's what will eventually cancel. So n plus 2 times n plus 1 times n factorial equals n plus 2 factorial. Alright, for the next one, which is a little tougher conceptually, I want you to look first, instead of at n minus 1 factorial, consider n factorial. That thing that we want so badly to cancel. That is equal to n times n minus 1 times n minus 2 dot dot dot. All the way down as far as we care to go. Now, this n minus 1 times n minus 2 dot dot dot, that's n minus 1 factorial. So this is equal to n times n minus 1 factorial. And that's equal to n factorial. Well, solve for n minus 1 factorial. N minus 1 factorial is equal to n factorial over n. Now, give this a little thought. Take a number. The number before it, factorial, is equal to that original number that you were thinking of factorial divided by that original number. Like 10 factorial, for example, divided by 10 is going to give us 9 factorial, which is 1 less than 10. So, putting both these together, we can actually work on our problem. We're going to get, in the numerator, n plus 2 times n plus 1 times n factorial, all divided by n factorial divided by n. Now we have a complex fraction. This division really puts this n somewhere up here. So this is equal to n times n plus 2 times n plus 1. The n factorial over here will cancel with the n factorial in the bottom to give us n times n plus 1. I'm reordering them in a nice, easy fashion, times n plus 2. Now let's try it out. Alright, let's use an actual number to verify the formula. Well, to verify the formula, let's pick a suitable n. How about 5? Any number will do. This original problem would be 5 plus 2, so that's 7 factorial, over 5 minus 1, which is 4 factorial. Well, we've already learned how to divide factorials. This is 7 times 6 times 5, and we stop there because all the 4, 3, 2, 1 are going to cancel with the 4, 3, 2, 1 there. So this is going to equal 7 times 6 times 5. Well, that's n. That's n plus 1, and that's n plus 2. So I think it's safe to say that our formula has been verified. So n plus 2 factorial over n minus 1 factorial, through a little bit of work, is n times n plus 1 times n plus 2.